All right, welcome back. Now in this video, we will see more about structuring the data. Now, before we proceed to making the logic, I want to split this read-write function, okay? Because we know that in the Siemens PLC, the programming is executed from the top network and the second network and the third network, all right? And here we have written read-write together. So in this function, we are reading and writing together. But what I want is, which is more optimized way of programming, we just read here, and then we have another network for logic. So the inputs are going to the logics and it will solve for the outputs, and then the outputs will be written to the PLC tag. So that's the more correct way. So what I'll do is I will just rename this one, rename this to read, okay, and I will just copy this one and paste here and rename that to write. And I should change this FC1 because it's the same name, so which we can do that here. This is FC2, okay? So now this is FC2. So if I go to the read function inside, I don't need the write function because we are just reading it. Delete it and close it. Similarly for the write function, don't read the inputs, just delete these. So we have individual read and write. So this is just reading the data, and this one is writing the data. So I will just drag this right here. Now this makes more sense. First we are reading the inputs, solving the logic, and writing the outputs. All right. Now coming back to our data conversion, data conveyor DB. In this DB, I would like to add more information. We have written for inputs and outputs, but I realize let's put some more information which would be quite interesting. So I will add a row and I will write here parameters. Oops. And in the parameter, I will make it again structure. Now, what is this parameter? Okay, this should not be like this. Wait a second, because this becomes under output. Hold on. Let me delete this. And now, yeah, now it's better. Parameters. Now it's a structure. Now, what could be the parameters in a conveyor? It can be the motor on time, conveyor on time or off time, or it can be the speed. These are the three parameters which I see in the conveyor we have in FactoryIO. So I will start with on time, which is my input, and that's integer. So I will type I on time. And the data type for on time, I would prefer to mention the on and off time in percentage. It would be in percentage. So I will take here integer from 0 to 100. Similarly, we have off time in integer. So write off time, that's also an integer. And the third parameter which I see could be the speed. That will also be in percentage. So again, integer. So all these three values are in percentage. So I prefer to take integer as a data type. Okay. So this is another, this comes under the same DB, data conveyor, the parameters. And another interesting structure I would like to add is the errors. That is also very important because conveyors can have some errors and we want to monitor that. So this is automatically structured. Now now there can be many errors, right? So let's say error 1. I'm not specifying as of now, but I'm just mentioning it. Error 2, error 3, error 4. It could be, you can make maybe up to 10 or 15 errors, however you want, depends upon what's your idea of showing the errors, but let's take only up to 4. And then I will write error com. Now what is error com? In the function we will mention if any of the error comes, we have an error common boolean bit which will be on, and this bit we will use to indicate that yes, the conveyor has error, so we will use the error com, but which error is that? Then we have to read which of the bit is on. Okay, but we just take error common error so that we don't have to write 4 errors everywhere. We just use one error common and use 2 for interlocking and stopping the conveyor. Okay, so we have these 4 structures. Now one more thing we will do in this video. You can see that in the main program I have started writing the ladder logic in network 2. Okay, let me just put some command, reading inputs, writing outputs, and here is the, let's say, conveyor logic. Okay, now if I started writing here conveyor logic for interlocking, for moving the speed, for showing the errors, it will be like so many letters here, you know what I mean? So, but I want this network to only for the conveyor logic, just to make a clean programming. So what I will do is, instead of writing the logic here, I will make another function, or I can also make another functional block instead of function. So I would prefer a new block, and let's take functional block. This would be extra block which we have only for conveyor, and let's try to program it in FBD. So I have in conveyor FBD here now. So this I would like to move here. Okay, this I prefer to be a clean programming, because we know we are reading the inputs in the first network, we have a logic in the second network, and then we are writing the outputs. And now inside this DB you can do whatever you want. This is sorry, inside the FB. So this is the FB. Here we can write the logic. All the logic which we write here will automatically be inside this one, and this will be executed after reading the inputs. So let's say we want to just, in this I'm just going to make a demo. So I need to start my factory IO. Suppose we just want to start the conveyor, start and stop the conveyor, and using the start stop push buttons. So let me open the scene which I made already. Let me Google it. Where is that? Academy, Siemens Advanced somewhere. Yep, this one. Okay, so we have, let me go back to the drivers. Yeah, we have start button at I0.0, stop in here. Okay, this is the correct logic. So now we open the DB again, because our input and outputs are here. Okay, not this one. Okay, one more thing, if you don't know, if you take an FB, it has a dedicated DB inside it. This comes automatically because FB stores the value and FC don't store the value. That's the reason FB has its own DB, FC does not have. So this DB come automatically when you take an FB. Okay, but we will go to data conveyor. Okay, so we need to latch the output. So I will see what are the instructions I have. So let's just take SR flip-flop. Now what is going to set the output? My input, which is start button. This is going to set my output, which comes here, which could be, okay, in this case we have only analog control. So if you see here, it's forward, reverse, and error. These are the indicators, and we have the speed here in QD 100. So what I'm going to do is I will take a memory bit, okay, just for the sake of explanation, which can be called as start bit. Okay, so here if you see the block in the input, I will take start bit. Sorry, it is not the input. This is my static start bit, because this start bit I'm going to latch, and this start bit is going to move the speed into the conveyor. So I will explain you how. So we have the start bit here, so I can take the start bit here. So I latch a start bit which is in the static, and then I'll unlatch the start bit using stop. But we know that stop is an NC, so which will always be on. So in that case I will take here inverse. Okay, so let's check this logic. Let's see if this makes sense to you. So I will download hardware and software into my PLC, which will take a couple of seconds. Reinitialize and load. Okay, now I will go online. No problem. I have to go to main, then go to online, and then go inside, then go online again. Okay, so we have this logic. Let's simulate it. Not simulate it, but actuate it. So here I have my panel. So I press start. Let me see what's going on. Drivers. Start is I0.0. I did not connect it. Now it's connected. Go back. Here again. Okay, so that's my panel. This will set my bit and this will reset my bit. But my conveyor is not running because conveyor does not have the speed input. So this is start and that's stop. So this you understand the lashing. Now using this bit, we are going to move the value. So we take here again instruction and we take an AND operator. We don't need this one. So if the start bit is on, I will copy paste here. We need to move the value, and the value which we will move should be the speed. So we need a move instruction. So we have a move instruction here. Now what we are moving the speed, and what is the speed? Which should be defined in the parameters. So if I move the parameter here, this will go out to the belt conveyor. All right, now the belt conveyor QR speed is here. Okay, wait, there is some problem. Okay, this one is in real, if you see here, so I have to convert this int into real, but what I can also do is I can also take it as real. That is no problem. In fact, we can also take time real, but here we are talking about seconds, so this will be in seconds. I don't know why I wrote percentage. Time, it should not be percentage, it should be in seconds. And this one should also be in second. All right, speed should be in percentage. Okay, so now we have no errors. Let's download the program. And one more thing before downloading, hold on a second. Now in the parameter, you will notice there is no start value, it's 0. So if I start the machine, there is no speed which is going inside the conveyor. So I can define the start value if I want. So let's take start value as 3.0. Okay, let it be like this. So now in this case, when the program is at run mode, automatically 3.0 will be moved into the parameters. Okay, and the belt will run at 3.0 speed, which is 30%. So let's download the logic now. Reinitializing the blocks. The logic is downloaded, and now you can see that this is 3.0 automatically. And if I go back to my factory IO, now we'll do the same thing. Start, and you can see that the belt is running, if you can see here closely, but it's running at the speed 3.0 because this is what we have defined in the parameters. Now if I go online here, this is the monitor value 3.0. If I change this value to, let's say, 7.0, this will run at 70% speed, so which is higher than 3.0. So the idea is we have to change the speed from the speed parameters, which can be from any source. The speed you can change this parameter from this potentiometer. You can also change this parameter from your SCADA system, or also from HMI or from MES, doesn't matter, but we have a defined speed parameters in the data block. That's the advantage why we use a data block, because you can control this data block from any source, because the addressing of the data block is quite unique. If I just write here, instead of data block, if I write here this input, which is my ID 100, which is dedicated to a potentiometer. If I just dedicate ID 100, I cannot change the speed from any other source. So what I can do is I can move this ID 100 into this data block, in the speed parameters, and I can control it. Okay, so since in this example we just have this potentiometer, let me go back. Oh, this is a software bug. Since I only have a potentiometer, we are not having a HMI or SCADA. What I'm going to do now is move the value from this potentiometer into the parameters, and then we can control it. Okay, so let's do that. So I will stop the conveyor. Okay, one more thing. there is incomplete programming. When the start bit is stop, let's do that here again. Okay, what's going on? Let me see if this is connected. Yeah, when the start bit is stop, you will notice that the value has been moved already. In this case, when the start bit was true, 7.0 has been moved inside. So belt is keep running. So in the case when you press the stop button, this will go off, and when this is off, we have to move 0 inside the speed. So I have to make another logic, maybe here. We'll just copy this one. Now here when the start bit is off, I will just move here 0, and this will stop the conveyor. Because here we are moving the integer value, the real value in the conveyor, so we have to make it reset. So now you can see that the motor is off, and I start the button, conveyor is running. It's running because 7.0 is moved, and if I stop, 0 is moved, and this conveyor is stopped. Okay, this isn't the case if your conveyor does not have a start bit. So we have made a start bit in our FP, and we are using this bit to move 7.0 or 0.0. This was the idea. Okay, so next in the next video I will show, this is quite a big video. In the next video I will show you how to use potentiometer, how to use this potentiometer and move the value from here to the parameter dB in a quite easy steps. So thank you for watching. See you in the next video.